Our objective for today, I can solve multi-step one variable equations involving proportions. Let's read it together. 1, 2, 3. I can solve multi-step one variable equations involving proportions. So I know it's the beginning of the week, so therefore think about this question. What is the concept for today? The concept. Tell your neighbor, please. So, yes, we're still on one variable equations, right? But make sure you circle or underline with red on your objective at the bottom of the page and circle with or underline with green for one variable equations. But with blue, I want you to box where it says proportions. Proportions. We're still solving multi-step equations. They're one variable. We know what they are. But today we're going to apply them using proportions. And we're going to revisit that to see what that means. You saw that in your pre-algebra class. So before we get there, first things first. We know what one variable equations are. Remember that? We know that they're not inequalities. And right now for one variable equations, we're looking at the ones that have exponents of 1 on the variable. Anything greater, we're not looking at right now. They are one variable, we're not looking at quadratics here. Second, we know the steps. Simplify, isolate, plot, check. Simplify, isolate, plot, check. And this one, I don't know why I switched it, but tell your neighbor the steps, please. Okay, so we know the steps, right? And we've been doing the first two most of the times, which is simplifying and solving for the variable. And I say for plotting and checking, we'll do that for you to check your work in some of the homework, right? So proportions, what are they? Here they go. First things first, a ratio. A ratio is a comparison of two quantities. The ratio of A to B can be written as A to B or A to B. The denominator cannot be what? 0. Okay? So look at this the way they write it. Everybody look up, please. Look how this is written, and we can make this into a fraction. Is that correct? Okay? So this is a good way of writing ratios, and it's usually when we compare two quantities. So kind of like if I ask, I wonder what the ratio of girls to boys in this class is. What do we need to do? Count how many girls, right? So let's count how many girls. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 girls. And I'm going to make it as a ratio, 11 girls. And let's count how many boys. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 boys. So the ratio of girls to boys in this class is what? 11 to what? And this could be written which way? 11 over 13. Everybody understand? That's what we call a ratio. Anyways, so let's continue. Here we go. Here we go. Let's continue. That's a ratio. Let's go to proportion. Proportion. If you're going to stay for lunch, that's fine. I need to finish this lesson. Here we go. A ratio, we know that it's two quantities that are comparing, and we can write it as a fraction. But look at this one, a proportion. Do you see one fraction equal to another fraction? Yeah, so basically a proportion is where two ratios are equal. Is this one ratio? Is this one ratio? Are they equal to one another? Yeah, okay. Now, rate. Rate, notice that the rate looks kind of like a ratio, doesn't it? Everybody look up to the screen. Here's my ratio. Look at a rate. However, for the ratio, we said 11 girls and 13 boys, but they are all what? People. They're the same type of things, right? Look at this. Here we have miles, and here we have gallons. We're talking about two different types of quantities. Everybody with me? So look at this. The definition for rate is the ratio of two quantities with, and circle with red please, different units. Different units. So we know that this is a ratio, but once the ratio has two different types of units, then it becomes what? A what? A rate. So it's kind of like this. Who's seen those competitions of the hot dog eating people? Have you guys seen those or heard of those? In New York, they do some competitions at Nathan's Hot Dogs, and to see who eats the most hot dogs. And this guy was getting 3 at a time and dipping them and eating them. Yeah. So I don't know, but they were really like digesting those pretty fast. So this guy was eating. Check this out. Everybody, look up, please. They were eating 6 hot dogs for every 20 seconds. Yeah, so he would get 3, dip them in water, stuff them in his mouth, and all of a sudden you can almost see that some of it he wasn't swallowing, and I mean he wasn't chewing, and he would swallow them, some pieces like full, and then he'll do the same for the next one. But what I wanted to show, check this out, isn't this a ratio? Yes. However, are they the same type of quantities? No, this is hot dogs and this is time. So therefore, once you see that it's 2 different quantities, it's a what? A rate. Yes. No, actually, that guy. I know. All right, let's continue. A unit rate. Guys, focus, please. A unit rate. Check this out. So rate is 2 quantities with different units. Are we there? This is still a rate, but it's called a unit rate because the denominator has a number 1. We're breaking that down to the unit. The word unit, if you hear it in Latin or in Spanish, what is it called? Uno. Who's heard of uno? That's when we talk about the number 1. That's why a unit, it breaks down to the lowest, which is a 1. Are we there? Now check this out. Everybody look up. Look at the rate that I gave you guys, 34 miles per gallon. So if I was to make this into a unit, what has to go on the denominator? 1. So therefore, what did I have to do to the 2 to get 1? Divide by 2. So therefore, 34 divided by 2 gives me what? 17. This is a unit rate. It's still a rate because we still have miles per gallon, but it's a unit rate because we broke it down to the 1 gallon or 1 unit on the denominator. So therefore, when I ask you to reduce to the unit rate, the denominator has to be a 1. When I ask you to reduce it to the unit rate, the denominator has to be 1. When I ask you to reduce it to unit rate, the denominator has to be 1. Tell your neighbor what I just said. All right, so let's continue. So let's look at this one. You have your first example there in front of you. It says the ratio of the number of bones in the human ear is the number, the ratio of the number of bones in the human's ear to the number of bones in the skull is 3 to 11. There are 22 bones in the skull. How many bones are in the ear? So everybody look up, please. Let's do this one together. With red, I'm going to write the first information they give us, the number of bones in the human's ear. So I'm going to box bones in the human's, what are they referring to first? Ears, okay? With green, I'm going to do the second information. Number of bones in the what? In the human skull. Are we there so far? Focus, please. So, the ratio that they give us is 3 to 11. Well, check this out. What is the first information? Which was the first information they mentioned? Was it the number of bones in the skull or the ears? Ears. So look at the ratio. The first number corresponds to the number of bones in the ear. So box it in red. The second part of the information is the bones in the skull. So guess which one corresponds to the skull? 11. So Do we know how to write this as a ratio, as a fraction? Yes, so therefore I write 3 over, what goes on the denominator? 11. Okay, so far so good. Then it says, there are 22 bones in the skull. So I'm going to box that with which color? Which color did I box the bones in the skull? Green. So I boxed 22 bones in the skull with green. So if I'm going to compare these two, where should I put the number 22 on this side? On the denominator, because the denominator corresponds to the bones in the skull. So this is 22. Are we there so far? Okay, look at the question. It says, how many bones are in the ears? We already know how many bones are in the skull, total bones, right? Do we know how many yet? No, so we're going to label that what? X. And to solve these, whenever you have a fraction equal to another fraction, we can use the cross product property. Okay, remember that? You're like, no, Mr. Q. All right, good. So what it says is that when you have a fraction equal to another fraction, you can use cross product. What does that mean? We can multiply across, like cross. So everybody look up. So I can multiply the 3 times the 2. What is 3 times 2? 66. Equal. What is x times 11? 11x. Does this equation look familiar? Yes. Now we can go and use our steps. We already did we simplify both sides of the equation? Yes, by using cross product. Now, next step, isolate the variable. What is 11 doing? Multiplying, so the inverse is 2. Divide by 11 both sides, so this is x equals 6. But I just don't want you to write that. You need to answer the question. How many bones are there in the ear? 6 bones. So you write, there are 6 bones in the ears. Yes? All right, so with that said, on the right-hand side, you have the next problem. Do the next one, 1B. I think I labeled it 2 on yours, but just write 1B. Do that one by yourself. See what you get, please. Once again, box your information. Make sure you keep organized. Write your ratio. Set it equal to another ratio, and then use the cross product property to solve. Okay, let's see. Who boxed with red marbles? Okay. And who boxed with green marbles? Okay. So therefore, which marbles were mentioned first? The red. So therefore, which of these two numbers corresponds to the red marble? The 6. Which one corresponds to the green? The 5. So I'm going to write my ratio. This is 6 over 5. There's my ratio. Now let's see what it says. It says there are 18 red marbles. 18 red marbles. How many green marbles are there? So let's see. So the 18 goes on the numerator. Is that correct? And the other one, we don't know what it is, so we label it X. So then, what is 18 times 5? 90. What is 6 times X? 6X. At the end, the 6 is multiplying inverse. We need to divide by 6 both sides. X equals 90 divided by 6, that's 15. So therefore, you need to write, there are 15 green marbles. This you need to write. Once again, because when we get to the semester final and final, your answers need to be written in sentences, those that are in word problems. Okay, because you need to understand what you're doing. You can't just be doing computation. All right, let's continue. Copy this next one. Yeah. All right. This one you don't copy, but this is the cross product property. We did it already, which means if we have one fraction equal to another fraction, we can do the cross product. So the only time that it works is when it's one fraction equal to another fraction. The only time that the cross product works is when we have one fraction equal to another fraction. The only time we have a fraction equal to another fraction, that's when the cross product works. So check this out. What if we have this? Everybody look up. What if I gave you the equation x over 5 equals 3/7 plus x? Will the cross product work there? No, because it only works when we have one fraction equal to another fraction. Here you have something being added to this fraction. Therefore, it won't work. Everybody with me? However, do we know how to get rid of denominators in an equation? Yeah. What is our LCD? What is our LCD? So we multiply the entire equation by 35, and that's how we work without the denominator. Okay, remember that? All right, let's continue. Copy this next one, please. Solve the proportion. You already know how to use the cross product property, so use it for this, please. All right, so this is just practice. We already know how to do these, but our cross product will go like this. What is 3 times m? 3m equals, what is 5 times 9? 45. So therefore, at the end we divide by 3, m equals 15. Hands if you got that. Okay, that is correct. Let's move on. Now on the right-hand side, copy this next one. Example 2b. All right, once again, for this one, use the cross product property. Let's see, negative 5 times 8, that's negative 40. Is that correct? Equals, what is y times 2? 2y. At the end, we divide by 2 both sides. This becomes y equals to negative 20. Hands if you got that. Okay? All right, so far so good, right? Okay, let's make it interesting. On the left-hand side, copy this one. The proportion, 6 over y minus 3 equals 2 over 7. And let's work this one out together. Here's the question. Do we have one fraction equal to another fraction? Yeah, look at this one. Even though it has more stuff on the denominator, but it's still one fraction, isn't it? Yeah, so here we go. The property should work. So therefore, 2 times this whole thing, which means we need to distribute to each of these. Is that correct? What is 2 times y? 2y. What is 2 times negative 3? Negative 6. Everybody see that? Okay. Equal. What is 6 times 7? 42. Do you know what to do from there? Yeah. Go ahead and finish it, please. Okay, let's continue. To solve for the variable, we need to start where there's addition and subtraction. Here we have minus 6. What is the inverse? Add 6. Add 6 to each side. This becomes 2y equals 48. The 2 is multiplying. What is the inverse? Divide by 2. Divide by 2. 1 times y is y. 48 divided by 2, that's 24. Okay, let's continue. Copy this one. You do it by yourself. See what you get. G plus 3 over 5 equals 7/4. Okay, so do we have a fraction equal to another fraction? Yes. Cross product property says 5 times 7, that's 35. Then we multiply these two, so therefore 4 times g, that's 4g. 4 times 3, that's positive 12, and that's equal to another. There it is. So where do we start? Where there's addition or subtraction, right here. What is the opposite? Minus 12 minus 12. That's right. Michael Jordan. 4g. So 23 equals 4g. What is the 4 doing? It's multiplying, so therefore we need to divide by 4 both sides. 4 divided by 4 is 1. 1 times g is g. How many times does 4 fit into 23? 5 times, and therefore we're left with 3/4. If you wrote it in decimal form, this is 5.75 equals 2. Okay? All right. So with that said, we know how to use cross product already. The rest is pretty much the same. The only thing I want to introduce, percents, your favorite from last year, right? Here it goes. Pens down really quick. Pens down. I just want to break down, guys, so that you understand what it means. Here it goes. Remember, this is the year of the Y. Yes, here it goes. It says percent. Okay? We know we've used these before, right? But what does it mean? Here it goes. I'm going to break it down. The word percent can be broken down into 2 parts. The first part, which is per. And by the way, the symbol, everybody remembers the symbol? Yeah, okay. Percent. The word per in Latin means by or times. Okay? Because in Spanish, who's heard the word por? Por or por ciento. Por ciento. Which means times. You need to multiply. So therefore, what would be the symbol for times? The multiplication sign. Are we there? Okay. The second part, cent. The word cent, who's seen something like this? Okay. But have you really paid attention to it? Let's look at the back side. If you flip the back side should look something like this. Who's seen that it says 1 cent? Right? So what does that mean? It means that it's a 1/100th. 1/100th. So therefore, in decimal form, it looks something like this. Does that make sense? Get it? Does that make sense? Anyway, so another way of writing this, pay attention please, another way of writing this, it could be written as or 1/100th. Are we there so far? So, this together, these two together are percent, or we can see it as this symbol right here. Are we there? So check this out. What if I wrote this? We know that this is percent. What if I wrote this? 25%. I can rewrite this like this. Everybody look up to the screen, please. 25 what? Times 1/100th. Does that make sense? That's why we do this. 25 over 100. Remember they used to tell you to write it over 100? That's where we get it from, because it's the word percent means to multiply times 1/100. Okay? Next, everybody look up to the screen, please. You can use the following proportion to find unknown values for involving percent. So here's one of the proportions that they gave you last year. Who remembers this? Part over whole equals percent over 100. Okay? If you don't remember that, here's another one. How about is over of equals percent over 100? Okay? Now check this out. Who noticed that the 100 doesn't change? Okay? So, look at this. Everybody look up to the screen. This side, we're going to have amounts. You don't have to copy this yet, just pay attention. This side, we have a total of what? Percent. Everybody with me? So therefore, we're going to use this setup in order for us to get percents and find percent or amount. So here we go. So here, we're going to look for wherever it says is, down here wherever we see where it says of, and right here whatever the percent is. Are we there? So check this out. Copy this one, please. Find 30% of 80. On the right side, I want you to copy this, please. Is over of equals percent over 100. And under here, I want you to write this. Everybody look up, please. A green box over a blue box equals a black box over 100, because the 100 never changes, right? But we do know that the right side of the proportion are what? Percents. The left side are the amounts. Are we there? Okay. Pens down, please. Eyes up here. check this out. What is the first number they give us? 30%. Where are the percent? On the left side or on the right side? So it goes right here. And then it says of 80. Where is the word of? So therefore, where does 80 go? On the bottom. What is the only one that we don't have? The top. So what do you think goes there? X. And do we know how to solve these using cross products? Yes, right? Okay. So therefore, make sure you write this down when you're solving these kind of problems for percentages, and get used to the format. Okay. There's another way of doing it, but I'll just go over that other way tomorrow. So homework. Pages 105 to 106, numbers 1 through 35 odd. Also, I need that handout signed. All right, guys, turn in your homework on your way out. Have a good day. Enjoy your homework. I'll see you guys tomorrow.